Let's go with the next question. A train is traveling at a speed of 90 kilometers per hour. So the initial velocity is 90 km per hour, which is equal to 90 into 1000 over 3600 meters per second. Brakes are applied so as to produce a uniform acceleration of minus 0.5, so which means that A is equal to minus 0.5 meters per second square. Find how far the train will go before it is brought to rest. So we know that if it is brought to rest, which means that your final velocity is 0. So we need to find S. So with all this, we see that you can use this formula because you have V, U, and A, which means that you can apply this formula to calculate S. So let's try that. So this means that 2 times minus 0.5 times S is equal to V square is 0 minus this whole thing, 90 into 1000 over 3600 whole square. So this means minus S is equal to minus of, if you take these off, which means, this one is going to be, this is going to be 10 by 4, which is equal to minus 25, right? It's primarily minus 25, the whole square. So that's the value. So which means S is equal to 25 square, or which is equal to 625 meters. So this is your distance traveled by the train. Let's go to the next one. So a trolley, while going down an inclined plane, has an acceleration of 2 centimeters per second. What will be its velocity 3 seconds after the start? Okay. So in this case, let's be careful. So we are using let's keep it to centimeters per second instead of meters. So let's that. So a trolley is going down and a plane has an acceleration of 2 centimeters per second, which means that A is equal to 2 cm per second square, and the time is 3 seconds. T is equal to 3, and we're saying that has an acceleration of this. What will be its velocity 3 seconds after 3 seconds after its start? So I think we should take the initial velocity as 0 here because we'll consider the initial velocity as the trolley was at rest, and then it started acquiring this acceleration, and then we want to see what is it that this trolley would have, the speed that this trolley would have acquired, right? So which means that let's consider the speed, let's consider u to be equal to 0. Now with this, what is the formula that we can apply? We have A, T, and U, and to find the velocity, I think we can apply this one. V is equal to U plus AT. So in this case, your V is equal to your initial velocity plus 2 times 3, right? So which means that your final velocity is going to be 6 centimeters per second. So that's your final velocity. Once again, excuse me for the lag here. I think that is taking some time. So what I'm trying to calculate here is the value of V, which is just going to be U plus AT, and that's just going to be 2 times 3, which is 6 seconds. Okay. So while this comes up, let me Let's go to the next one. The last one is a racing car has a uniform acceleration of 4 meters per second. What is the distance it will cover in 10 seconds after start? So similar to the earlier situations, let's see. The racing car has a uniform acceleration of 4 meters per second, so which means that A is equal to 4 meters per second square. The distance covered in 10 seconds, which means that T is equal to 10 seconds, and after the start, so which means that U is equal to 0, right? So we have A, T, and U, and we need to calculate S, which means that S is what, right? So we can apply this formula, ut plus half et square, right? So which means that S is equal to ut, which is 0 because U is 0, plus half of acceleration is 4 and t square is 100. So which is equal to 200, right? It's going to be 200 meters. So the value of the distance covered is going to be 200 meters. Right. Okay. Let's come to the last one. A stone is thrown vertically up in an upward direction with a velocity of 5 meters per second. If the acceleration of the stone during its motion is 10 meters per second square in the downward direction, what will be the height attained by the stone, and how much time will it take to reach there? Okay. If the acceleration of stone during its motion is 10 meters per second square in the downward direction, what will be the... Okay. So let's try to solve this one. So what you're saying here is this stone. This is the ground, and we have a stone that was thrown from here. Let's take the stone had to travel this distance, and then it is coming back to the ground here, right? So this is the situation. It is thrown vertically in the upward direction with a velocity of 5 meters per second here, right? So which means that this stone was thrown with a velocity of 5 meters per second. So by the time you threw it, the initial velocity u was 5 meters per second. Now this means that because there is gravity, right? Which means that the stone, before it comes back before it changes its direction, at this particular point it would have the final what would be the velocity of that stone at this particular point, because if you recall, at this point the stone changes its direction to start to fall down, right? So what started with a velocity of 5 meters per second, the velocity would have changed to your final velocity would actually become 0, right? 0 meters per second, because only when it becomes 0 seconds, it will start to fall down. So which means that there is an acceleration in the opposite direction, right? Something is pushing the stone down, so that is why it is the stone is moving up, and at the moment it reaches 0, it means it starts to fall down. So there is actually a negative acceleration, which is what we call as gravity, right? Any object will fall on the earth, right? So that negative acceleration is what is 10 meters per second here. So the acceleration encountered is 10 meters per second, which means that A is equal to 10 meters per second square. Now with this, we want to find out what is the height that it would attain, which means that what is the distance it would travel. So the whole problem can be rephrased as an object that is moving with an initial velocity of 5 meters per second, and there was an acceleration of 10 meters per second square, and it reached a final velocity of 0 meters per second. What is the distance it would have covered? Right? So this is your distance here. So what is the formula that we can apply here? We can apply. We should be able to apply this one. 2as is equal to v square minus u square. So let's try that. 2a yes is equal to b square minus u square. So in this case, 2a yes is 20 yes is equal to 0 minus 25, and s is equal to minus 25 by 20, which is equal to minus 5 by 4, which is equal to minus 1.25 meters. Right? Is it right? Yeah. Yeah. So because it is displacement, and then there is negative acceleration. That is why there is a value of minus here, which means that it has actually gone up and it has come down. If you consider this part, the stone would have covered a distance of 0.15 meters from here to here, but when you consider from this point to this point, it has actually moved up. So that is why you have the negative sign here. So we are considering this one. So the magnitude of the displacement is only 1.25 meters. So the better way to state that is the magnitude of displacement is equal to 1.25 meters for the stone. Yeah.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share, and subscribe this with your friends. Thank you.